third fluoride was obtained with Swarnima in both year of experiment. And among the interaction studies, it was found that interaction of 20 GY with Swarnima obtained with maximum diameter of third fluoride, and during second year it was with interaction of 40 GY with cultivar Josna. So in post-harvest condition, we will prefer maximum days taken to open the first fluoride, because slow opening is the best quality during post-harvest condition. So during first year, it was seen that among treatments, slow opening is obtained with control, while during second year, it was found non-significant. And among varieties, slow opening of first fluoride was obtained with cultivar Josna during first and second year both. So maximum number of open fluorides during post-harvest condition was observed during first and second year. So among treatments, it was found that gamma radiation of 20 GY was found with the maximum number of open fluorides during first year of experiment, and during second year it was also with 20 gamma rays. And among varieties, Mohini exhibits with maximum number of open fluorides during both the year of studies. Some morphological changes I have observed during my experimentation. So some yellowing, drying and lack of chlorophyll at the tip of leaf blade, and narrowing of leaves were observed in cultivar Urvasi at 50 gamma radiated materials, while bent neck with some curled leaves was also observed at 50 GY in cultivar Pusa Urvasi. In flowering condition, a lighter shade of light purplish red color was observed in the outer tepal of cultivar Urvasi at 50 GY condition. These are all abnormalities I have observed during gamma radiation. In other variety, cultivar, Pusa Kiran, some abnormal spike growth was observed at 40 gamma irradiation, which failed to open as it dried rapidly. In figure 6, it was seen that there is double fluoride instead of single fluoride, which was unable to open at 50 GY of gamma doses. In another spike of Pusa Kiran, it was observed there is a purple macule seen in the mutant material when compared to parent. As we have seen in figure 7, there is no macule formed in Pusa Kiran, but in mutated material there is a formation of macule. Yes, yes, sir. Yes, sir. Yes. Yes. Yes, yes, sir. Sir, there is a one evolved mutant. I will. Yes, yes. Yes, yes. Yes, yes. सर दिखा रहे उसे हैंग हो गया है एक्चुअली ये हैंग ही हो गया तो आप समरी पर এইটুকু দেখিয়ে দিবে। So this mutant was evolved with change in macule shape, size, margin, length, and width of stripe. The macule color in mutant was strong purplish red B color of a group chart red purple group, and in parent it was of deep purplish pink. ये सारी सर यही mutant है जो dissection. The length of macule was also varying from mutant, and stripe color of mutant is deep purplish red, while parent is deep purplish red B color. Prominent variation in tepal shape. Outer in parent the tepal shape is ovate, while in mutant the outer tepal shape is elliptical, and in inner tepal shape is ovate, elliptical and elliptical. There is a variation in tepal color, which is in mutant it light greenish yellow C color, and is parent is light greenish yellow B color. And this is the inner tepal dissection. This is the change in anther color. Variation in anther color in mutant it was of pale yellow D color, while in parent it was light pale color. Similarly, style color at apex in parent was white, in mutant it was pale white color. So this is the dust study of both parent and mutant of Pusa Shubham. We change in all the character. Sir, conclusion, sir, ऐसे ही बोलते थे. Sir, one evolved mutant is there, Pusa Shubham.
Hello.
Brief करना चाहिए. Only result.
Educationist presentator Pratik Kumar Sasasnia. He's from CSIR, CIMAP, Lucknow. Influence of planting, the topic is influence of planting methods and nitrogen levels on the growth, yield, quality parameter of menthol mint.
इन्फ्लुएंस ना क्या पढ़ा अपने आप करें सर तो सर आप तो ठीक है सर नहीं बता दो क्या बता दो इन्फ्लुएंस ना इन्फ्लुएंस है सर इन्फ्लुएंस इन्फ्लुएंस ऑफ प्लांटिंग मेथड्स एंड नाइट्रोजन लेवल ऑन ग्रोथ yield and quality of menthol mint okay yes sir माइक मेरे पास है सर mentha arvensis linnaeus variety sim unnati you can change from right no कौन introduction है mentha arvensis is a herbaceous plant in lamiaceae family menthol mint contains essential oil are नहीं माइक तो सर यूज ही कर रहे हैं ना menthol mint contains essential oil are commonly used in medicines. Okay, several compounds have been isolated from these oils, mainly menthol and methone, isomethone, and other phytochemicals. Caterpinone has been studied in context of sustainable agriculture. Its eco-friendly nature makes it an attractive alternative to synthetic. अरे नहीं है सर सिंथेटिक केमिकल्स इन फार्मास्यूटिकल हाँ 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 जी 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 बढ़ा दो बढ़ा दो अच्छा फ्लैट है ना by 50% fertilizers by 50% okay conclusion नहीं सर conclusion सर है सर conclusion है सर नहीं नहीं we are just reading it writing we are just he is a student I am a student he is a scientist तो सर प्रतीक है सर प्रेजेंटेशन तो सर मैंने ही किया है ना तो वही तो सर है 50 अरे सर 50% नो सर
Okay, online, I think on VC Dimple Kamboj, she's here. Can we connect her online through VC? Dimple Compose, yeah. Are you there, Dimple ma'am? आप हैं? Can you hear us? आप अपना mute कर सकते हैं. Your presentation is next from Dimple Compose from PAU Ludhiana. She will be presenting on a topic nitrogen management practices in conjunction with farmyard manure improve soil properties and fruit yield of chili. So ma'am, can you hear me? Hello? Yes.
Ma'am, ma'am, due to network problem, I will deliver the presentation after 30 or 40 minutes.
Okay, all right. She's requesting for presentation after 30 minutes due to some network issues. Okay. Kamalpreet Singh, is he online? Yeah. Kamalpreet Singh, sir, can you hear us?
Hello,
Yes, sir.
Good evening, ma'am.
Good evening, sir. Kamalpreet Singh, next presenter from Punjabi University, Patiala. Right, sir?
Yes, yes, ma'am. Yes.
Okay, sir, you are the next presenter. Please kindly present. So kindly share your slide, please. His topic is regional disparities in wheat cropping patterns in Himachal Pradesh.
Kamalpreet, are you listening?
Hello.
Are you
Yes, sir. Yes, sir.
So share your slides, please. Go ahead.
Sir, I am sharing.
Problem?
Uh, uh, uh,
आ गया. चलिए.
Hello.
Go ahead.
Good evening, everyone. My name is Kamalpreet Singh, and I am a research scholar of Geography Department of Geography, PIB University, Patiala. I am presenting and my topic is regional disparity in wheat cropping pattern in Himachal Pradesh, a part about sustainable development. First of all, I start with introduction. Wheat is an important staple crop grown in the Himachal Pradesh. However, regional disparity in wheat cropping patterns have uh, it's, hello, am I audible? Hello.
हाँ आप आगे बोलकर इंट्रोडक्शन छोड़ दीजिए. चलिए.
These are my objectives of this study. To analyze the spatial and temporal pattern of wheat cropping pattern in Himachal Pradesh from 1990-91 to 2020-21. To categorize district based on the share of wheat cultivation into high, moderate, and low categories. To identify the factors influencing changes in wheat cropping pattern. To provide sustainable solution to address region disparity and improve agricultural equity. This is the methodology I used for my study. First of all, data collection. I used annual season and crop reports of Himachal Pradesh from 1990-91, 2005-06, and 2020-21. Districts are categorized into high, above 45%, moderate, 25 to 45%, and low, below 25%. Wheat cultivation zones based on the percentage share of wheat cropping area. Temporal changes in wheat cropping pattern are calculated from three periods: 1990-91 to 2005 to 06, 2005-06 to 2020-21, and 1990-91 to 2020-21. Its overall changes in wheat cropping pattern. Tool used for it present value and changes, and graphs and maps for visual representation of trends and disparities. This is my research area. base map of Himachal Pradesh. Himachal Pradesh is another state in India. It is a 55,000. 50. हेलो बट सर क्या सर? हेलो
सर नेक्स्ट स्लाइड को चलिए, सर बोल रहे हैं.
हाँ जी, कैन आई कंटिन्यू?
हाँ, कंटिन्यू.
हाँ
But you know, in
सर मैं एक्सप्लेन कर दूं सर, सीधा सीधा एक्सप्लेन कर दूं.
हाँ, सीधा एक्सप्लेन कर दो.
सर जो जो 1991 में बीट का जो क्रॉपिंग पैटर्न है उससे हमें पता चलता है भी जो वेस्टर्न डिस्ट्रिक्ट है उसमें से हमीरपुर वो ज्यादा क्रॉपिंग पैटर्न के एरिया में अंडर आता है. तो और मॉडरेट में जो वेस्टर्न सदर्न और नदर्न वेस्टर्न पार्ट है सर, लाइक उसमें ज्यादातर डिस्ट्रिक्ट आते हैं क्योंकि ये डिस्ट्रिक्ट पंजाब के साथ लगते हैं जो फर्टाइल प्लेन्स है जो शिवालिक के हिल्स पे आते हैं सर. और उसके कंपैरिजन जब हम देखते हैं जो ईस्टर्न डिस्ट्रिक्ट है लाइक किन्नौर हो गया, लाहौल एंड स्पीति हो गया, यहाँ पे उसका जो टेरन है, क्लाइमेटिक कंडीशंस हैं और एग्रीकल्चर पॉलिसीज वगैरह बीट को सही नहीं बैठती सर. इसलिए वहाँ पे जितना भी ईस्टर्न पार्ट्स है सर, वहाँ पे जो मेन और मेजर प्रॉब्लम है बीट के लिए वो शॉर्ट ग्रोइंग सीजन है सर. मतलब जो विंटर्स में स्नोफॉल होती है, दैट्स व्हाई बीट्स नॉट पॉसिबल हियर.
तो
Same,
when do plant?
sir, in summers, like
हाँ.
winter is grown in winters. Sorry, wheat is grown in winters, but in according to climatic conditions, in Kannauр and Lahaul Spiti, there is a little share which is grown in summer.
Winter. चलिए.
हाँ
समर
जी,
बीट होता है, समर बीट होता है, ठीक है.
बिल्कुल सर. और दिस ये 2020 का मैप है सर. यहाँ पे हम देख सकते हैं जो वीट का क्रॉपिंग पैटर्न है डे बाय डे और ये डेकेड वाइज यहाँ पे बढ़ता जा रहा है, स्पेशली इन वेस्टर्न डिस्ट्रिक्ट में. यहाँ पे हम देख सकते हैं पहले हमीरपुर था, अभी हमीरपुर के साथ साथ बिलासपुर उन्ना भी हाई डिस्ट्रिक्ट का हाई कल्टीवेशन में आ गए हैं. उसके अलावा जो उसके रिमेनिंग एरियाज है सर उसमें वीट जो उसका शेयर कम होता जा रहा है क्योंकि वो अभी डाइवर्स क्रॉपिंग सिस्टम आ गया. मतलब सर कि जो ये डिस्ट्रिक्ट है, सेंट्रल हो गए डिस्ट्रिक्ट हो गए, ईस्टर्न डिस्ट्रिक्ट हो गए, लाइक शिमला में आ गया, कुल्लू में सर जो हॉर्टिकल्चर है वो डे बाय डे इंक्रीज हो रहा है. लाइक एक जिसकी वजह से जो बीट के अल्टरनेटिव सर वो फ्रूट्स हो गया, वेजिटेबल्स हो गया, बार्ले हो गया, वो इंक्रीज हो रहे हैं. दैट्स वाई जो शिमला और कुल्लू अभी लो कैटेगरीज में आ गए हैं. ये सर ग्राफ है जिससे हम पता लग जाए ये परसेंट शेयर है. और इसके साथ साथ 1990 से लेके 91 2005 और 6 से जो चेंजेस हैं सर वो इसमें सारे लिखे हुए हैं हमें. और चेंजेस से सर हमें ये पता चलता है भी जो जितने भी वेस्टर्न डिस्ट्रिक्ट है उसमें पॉजिटिव चेंज आया है भी. उनका जो स्पेशल क्रॉपिंग पैटर्न है वो इंक्रीज हुआ है एज कंपेयर टू सेंट्रल और ईस्टर्न डिस्ट्रिक्ट लाइक मंडी, सिरमौर, शिमला उसमें. और जो ईस्टर्न है किन्नौर और अपना लाहौल और स्पीति हो गया सर, इसमें नेगेटिव चेंजेस आया है सर. हाँ, ये ओवरऑल चेंजेस है सर. ओवरऑल में भी सर हम जो देखते हैं बिलासपुर, ऊना, सोलन और कांगड़ा इसमें पॉजिटिव चेंजेस आए हैं. ऐसे ही जो हमारे कुल्लू, शिमला, किन्नौर, लाहौल स्पीति है, मेन जो सेंट्रल डिस्ट्रिक्ट है उसमें जो इनका जो शेयर है वो डे बाय डे कम होता जा रहा है क्योंकि इसमें जो जैसे मैंने पहले भी बोला है कि अब जो उसमें डाइवर्स क्रॉपिंग सिस्टम. हेलो,
Yes, they are going to vegetable.
हाँ जी, यस सर. वहाँ पे अब हॉर्टिकल्चर फ्रूट्स की कल्टीवेशन ज्यादा होने लगी है सर. एग्जांपल है सर 2021 में शिमला का 70% एरिया सर, 17% एरिया इज अंडर फ्रूट कल्टीवेशन. दैट्स व्हाई इट्स कॉल्ड एप्पल बॉल ऑफ इंडिया. ठीक है, और क्योंकि बेस्ट क्वालिटी एप्पल सर. इसकी वजह से क्या होगा भी अब जितना भी हॉर्टिकल्चर है सर वो जगह ले रहा है. जो ये स्टेपल क्रॉप्स है राइस, व्हीट, मेज, ये सब वेस्टर्न डिस्ट्रिक्ट की ही साइड रह गई है. तो वेस्टर्न जो जितने भी वेस्टर्न पार्ट्स हैं जो पंजाब के साथ लगते हैं, हरियाणा के साथ ज्वाइन करते हैं उन होता है. जो सर जैसे ग्राफ में साफ पता लग सकता है जो बिलासपुर में हमीरपुर एक पॉजिटिव ग्रोथ शो कर रहे हैं एज कंपैरिजन टू लाहौल और स्पीति, किन्नौर इसमें नेगेटिव है. ठीक है सर, ये कुछ पॉलिसी इम्प्लीकेशंस है जिसको हम जो रीजनल डिस्पैरिटी है इन बीट कल्टीवेशन है उसका हम रिड्यूस कर सकते हैं। लाइक एक इरिगेशन सिस्टम दे सकते हैं, क्लाइमेटिकली साइलेंट फार्मिंग प्रैक्टिस हो सकती है सर, टेक्नोलॉजी में इम्प्रूवमेंट कर सकते हैं। सो इसमें जो और जो सबसे खास है वो है सर कोऑपरेटिव टेक्निक्स ला सकते हैं सर, क्रॉप डाइवर्सिफिकेशन को इनकरेज कर सकते हैं, जिसके साथ ये ब्रीड का जो एक प्रॉब्लम है सर उसको उसका सोल्यूशन हो सके सर। और here is my conclusion. सर इसको पढ़ो के रहने दो।
वेरी गुड इंफॉर्मेशन कमलप्रीत।
हाँ
काम करो बेटे,
यस सर, यस सर।
आपने बहुत अच्छा पेज रखा है, लेकिन जब जब प्रेजेंटेशन देते हैं ना इनको रिड्यूस।
हाँ जी सर,
बहुत अच्छी इंफॉर्मेशन है, इज गुड
ओके सर, ओके
व्हेन यू मेक दिस ओरल प्रेजेंटेशन, इन दैट केस मेथड मटेरियल इंट्रोडक्शन ये नहीं आनी चाहिए, ठीक है?
ओके सर,
गुड।
ओके सर, थैंक यू सो मच सर।
According to him, those areas which are on the higher side, high altitude, shifting to the vegetables, it is becoming more economical as compared to wheat cultivation.
Yes sir,
Punjab and Haryana, their wheat is increasing because of the increased temperature
yes sir,
and
yes sir,
available demand. Una was part of Vishakhapatnam.
yes sir.
Thank you very much.
Thank you so much sir, thank you so much.
Now next is
Thank you so much, Kamalpreet. Next is Rinki Sarma Panda,
okay, ma'am. Rinki
ICAR-IARI, New Delhi, on a topic of
टॉपिक उसको मालूम है मैडम, हार्नेसिंग द पोटेंशियल ऑफ वाइल्ड लेथारस है, दिस इज स्पीशीज एनहांस ग्रास्पी। ठीक है, आपका भी इंट्रोडक्शन आता है मुझे हटा दें, वी विल टू द नो जेटिस में है मैडम, जेटिस
check.
Currently, I am pursuing my PhD in the Division of Plant Genetic Resources from ICAR, Indian Agriculture Research Institute, New Delhi. Here I am going to present a part of my research work with the title Harnessing the Potential of Wild Lathyrus Species to Enhance Graspy Crop Improvement. Well, graspy, which is commonly known as khesari in the eastern region of India, is nothing but a gracious gift of God globally. This is because of the hardiness and the low input requirement of this crop, which make it capable to thrive in different type of extreme stress condition like drought and flood. And apart from this graspy is coming under the genus Lathyrus, which is the largest genus under the tribe Vicia. And it includes more than 187 species in this genus. And it is also an ideal crop under the rice fallow land, which is mostly you can find in eastern region and northeastern region of India. Well, let me discuss some diverse uses of this species. The most commonly the grain of this species we are using for pulse purpose like for preparation of dal, and including that also for the cultivated Lathyrus, that is Lathyrus sativus. The leaf we are using for as a leafy vegetable in the part of Bihar, Jharkhand, Chhattisgarh. Most commonly you can find in the market in this leafy vegetable. And apart from this, some species like Lathyrus ochrus and other species are also used as for fodder purpose. And in market also commercially you can find the seed of Lathyrus odoratus, which is a species that has ornamental use. And apart from all this, you can also find in market the commercialization of honey that is made up of Lathyrus flora. And you might have thinking, if I am telling all these benefits of this species, why this crop is not much known to everyone? Well, there is a major constraint in the commercialization of this cultivated Lathyrus. The major constraint is the presence of beta-ODAP, that is beta-oxalyl diaminopropanoic acid, which is a neurotoxin. The presence of these neurotoxins make this crop to make the people causing neurolathyrism disease, which is caused by overconsumption of this crop. And the solution lies in the wild Lathyrus. This is because in the wild Lathyrus only we can find the gene which is responsible for the low beta-ODAP content. But here the problem arises, where only few Lathyrus species were domesticated and characterized till now, and also there is a narrow database available regarding the pollen biology and the cross compatibility of these species. So, well, to overcome all these challenges, we have started our work with the use of 272 accessions of 30 different species, which we have imported. These species were acquired from 4 different countries, including Spain, Australia, USA, and Hungary. And we have all these species, you can see the most of the germplasms are from Lathyrus caesura species and Lathyrus sativus, Lathyrus ochrus, and Lathyrus anus. Here you can see the first work we have conducted the characterization of wild Lathyrus genetic resources based on the 52 different agromorphological traits, which include both the qualitative traits and quantitative traits. First we conducted on the basis of 2 descriptors. One is minimal descriptor that is developed by ICR NBPGR New Delhi, and another one is descriptor developed by IPGRI. Here are the list of all the 23 quantitative and including the 29 qualitative traits which we used for this analysis. And after that, we have grown all these species in 2 different conditions. One is the Pusa farm NBPGR, where we gave them the normal photoperiod condition. And next one is the crop wild relative garden established by NBPGR under extended photoperiod condition, where we used artificial light condition to give them extended photoperiod condition. And the experimental design used here is the augmented block design with the use of 5 different check, that is the release. Along with the 5 check that are the released varieties. After conducting all the analysis, we have found one species among them, that is Lathyrus pseudocaesura. It flowered yearly in both the photoperiod conditions. And Lathyrus odoratus, which I previously told that it has ornamental uses, it is found to be the photoperiod insensitive. That means it flowered at the same time in both the photoperiod condition. And another species, that is Lathyrus criminum and ochrus, that they found to be with higher biomass, which can be the potential source for fodder preparation, fodder purpose. Along with that, we have also gone for the frequency distribution curve. Here you can see where the agromorphological characterization of all the traits shows the wide range of variations across all the traits examined. And here you can see the most wide range of variation in the we found in the yield related trait like number of pod per plant, and seed related trait like 100 seed weight. And here you can see the scatter plot and the correlation analysis, where you can see the significant high correlation between the number of pod per plant and the plant height, along with the significant correlation between plant height and 100 seed weight, where you can see this result also aligns with the previous published results which are undertaken on the different Lathyrus species. After conducting all the analysis, we concluded with 3 different important germplasm for these important traits. First is from Lathyrus criminum, that is for plant height. Second one is from Lathyrus pseudocaesura, that is for early flowering trait. And third one is from Lathyrus caesura. This is for higher seed weight. Along with this, we are also carrying out the development of species-specific descriptor, where for this crop wild relative, there is no descriptors. So our efforts are on the progress to develop these descriptors. And also, I have done the standardization of in vitro techniques for this graspy wild hybridization, where I collected the flowers of different species. Then I stained them using different staining method. One is from acetokinamine staining, and another one is fluorescence diestate staining. Here you can see how I calculated the viable percentage, the viable pollen percentage. After calculation of this viable pollen percentage, we have prepared the cluster dendrogram, where I can see the Lathyrus tingitanus and Lathyrus criminum. These 2 species shows the highest percentage of viability. And after this, also, we have conserved them using liquid nitrogen for their cryopreservation. And in this picture, you can clearly see there is almost no difference between the cryopreserved pollen and the fresh pollen viability. And third, after all, we are also initiated the pre-breeding work on this species, and successfully we got the F1 hybrid when we are using Lathyrus sativus, that is the cultivated one, as female parent, and Lathyrus caesara, Pseudocaesara ocrus, and Aphicarpus as male parent. But here you can see this is not due to because the viable pollen, as we already examined the pollen viability. So we can tell the development of hybrid in this Lathyrus crop is not only dependent on the viable percentage of the viability pollen, it can be dependent on the pollen pistil incompatibility or other parameters, like maybe the pollen grain do not germinate. If it is germinate, maybe it cannot reach up to the ovary or other reasons. Well, out of all the experience, I would like to conclude with some practical know-how. We are working on crop wild relatives, the major important thing is the identification of proper wild species before starting of any research work. And also we have to know that the dormancy breaking method, because in many cases we can see the wild species are not germinating in normal conditions. So we should know the proper dormancy breaking method for all the species. And also, we should know the ideal environment for their growing with the purification of seed and trade prioritization. With this, I conclude my slides. Thank you.
Well, see, madam, how you have made the presentation nicely. Very good.
Thank you so much, sir. Thank you so much, ma'am. Next, Nala Sandeep.
Neither is there.
Sandeep is, he's here? No?
Ma'am, actually, I'm joining online, ma'am.
Okay, you will be
I'm
joining
actually
on.
joining on.
Okay.
Shall I start, ma'am?
Yeah, sure.
Can you see the slides, sir?
Yes, go ahead.
Oh. So, can you see it in full screen, sir? Because I cannot see it here. Is it visible, sir? No?
Yes, it's okay.
So, today, good afternoon, everyone, respected panel members. So, I'm Nalla Sandeep. I'm a PhD research product from Department of Genetics and Plant Breeding, Schwartz. So, my topic here is floral biology that reveals the mechanisms underlying species-specific pollination in buckwheat, Phagopyrum species. So, Phagopyrum species, in the sense, only two species. I mean, there are 6 species, but we are currently focusing on 2 species. That is Phagopyrum esculentum, known as common buckwheat, and Phagopyrum tataricum, which is known as tatary buckwheat. So, coming to the introduction, so buckwheat is not highly known as a nutrient resource, but in the current trends of evolution, addition of nutrients to the food, we are going towards addition of other nutrients into the existing foods. So in whole grain, atta, and everything, current days, buckwheat is also used as a supplement. So buckwheat is a pseudo cereal with immense potential for agriculture diversification, because despite of the nutritional and ecological benefits, the shift towards product-oriented agriculture has led to the underutilization of these crops. So the study focused on 2 primary species, common buckwheat and tatary buckwheat. The actual difference between the common and tatary buckwheat is the pollination mechanism, because common buckwheat always shows about, it consists of self-incompatibility, which does not allow it to uh, make self-pollination. So it relies only on obligately on cross-pollination. So the understanding these mechanisms is critical for designing breeding programs and developing genotypes that are resilient to diverse agroclimatic regions. So coming to general floral morphology, so this is the floral diagram, the floral picture. So floral morphology of common buckwheat and tatary buckwheat exhibit distinct characters that reflect their evolutionary adaptations. Both species have flowers with 5 sepals, 8 stamens, and a tricarpellary apocarpous superior ovary. However, the common buckwheat flowers are typically open and heterostylous, promoting cross-pollination, whereas tatary buckwheat flowers are cleistogamous and facilitate self-pollination. So these are the floral parts. So coming to this is the floral parts of the common buckwheat, and these are the floral parts of the tatary buckwheat. So coming to the type of growth and incompatibility studies. So common buckwheat exhibits an indeterminate growth pattern, allowing the prolonged flowering and seed production. This characteristic is tied to the continuous activity of its meristems. which can produce reproductive structures as long as the resources are available. So in tertiary buckwheat, the flowers are determinate, the inflorescence is determinate, and the flowering period is shorter and also synchronized. Environmental factors such as temperature and photo period significantly influence the floral dynamics of both species. For instance, common buckwheat shows varying response to day lengths, with some cultivars being photo period insensitive, while tertiary buckwheat exhibits more uniform responses. So these are the the differences between the different types of floral mass. This, as you can see here, is a pin flower. In the pin flower, the stamens lie below the stigma, and in the thumb flower, the stamens lie above the thumb flower. And in tertiary buckwheat, as you can see in the figure 5c and 5f, this is tertiary buckwheat, which is self-compatible and is of homostylous nature. So the flower from the pollen from pin flower cannot fertilize another flower on the same plant uh, the same floral morph. I mean, the pin flower cannot fertilize another pin flower. It should always fertilize a thumb flower. So the pollination in this is mostly governed by insects. Pollinators such as insects. So the pollen dynamics of the pollination dynamics of these species is currently mostly governed by pollinators. So as to provide attract pollinators, these flowers should develop certain features so as to attract pollinators. So coming to features, like these are the developmental stages. I haven't put a slide to show the different features that they have developed, but so as to this, you can see the compatible crosses and incompatible crosses. This is a thumb flower and this is a pin flower. So when the pollen from a thumb flower falls on the stigma of pin flower, then it starts to produce a seed. In vice versa, pin flower to thumb flower will produce a viable seed. But the pollen from thumb flower to thumb flower will not germinate, will not fertilize the ovary, so it does not produce seeds. So this is a major problem that affects the production of common buckwheat. So as to attract more pollinators, what the common buckwheat does it, to attract pollinators, they should give some rewards. So in order to give rewards, the buckwheat flowers tend to produce more nectar, or they might show different color variations so as to attract the nectars. So uh, coming to the nectaries, so these are the floral parts of common buckwheat are arranged to optimize cross pollination. The sepals are typically white or pink from protective structures around the reproductive organs. The stamens are positioned to ensure efficient pollen transfer, while the stigma remains glossy and receptive during the initial hours of anthesis. In contrary, tertiary buckwheat does not exhibit any simpler arrangements, and the self-monitoring mechanisms reduces the need for complexities. So the self-compatibility incompatibility is totally governed by its S super gene. Sir, are you able to hear, sir?
Yes, go ahead, go ahead.
Oh, the self-incompatibility in Phagopyrum esculentum, like you can see here, is governed by the S supergene, which contains five different genes packed together that govern the style length, styler incompatibility, regulates pollen incompatibility, if it influences pollen size, determines anther height or filament length. So the confusion here is the most research think that conclude that this may be a sporophytic self-incompatibility, as the pollen is receptive on the stigma but is not able to fertilize on the stem, fertilize the ovary. But in case but there is a high confusion in this part. But our research has not I cannot conclude my total findings here. But the thing is, the S super gene governs all the five genes in the S super gene govern the self incompatibility in these species. So development of breeding programs that that can overcome these differences will be useful for the production of will be useful for the improvement of the production.
Thank you very much.
So, in conclusion, the floral biology of buckwheat species reveals the distinctive reproductive strategies, highlighting the intricate mechanisms underlying species-specific pollinations. So, these findings emphasize the critical role of floral traits, nectar production, and pollen dynamics in determining the reproductive success. So understanding these mechanisms improves a strong foundation for breeding programs aimed at addressing challenges like sampling compatibility in common buckwheat while optimizing the self-compatible traits of tartary buckwheat. So this research underscores the potential of the buckwheat as a sustainable and versatile crop that can contribute significantly to agriculture diversification, yield stability, and food security, particularly in regions with variable environmental conditions. Thank you, sir. So I would like to acknowledge my professor, my guide, Dr. VP Sahi, my co-advisor, Dr. Prashant Kumar Rai, and also to thank Dr. GP Singh, Director NBPGR, and Satish Kumar Yadav for the supporting the materials required for the research. And I also extend my thanks to Dr. Kuldeep Tripathi for providing the ideas for the work on the aspect
Thank
of
you
floral
so
biology.
much. Next, Pasupati Nath Singh.
Now, who is next?
Pasupati Nath Singh. He will
जी
be
हेलो
presenting online. Yes,
हेलो
sir,
मैम
from
आई एम
BHU
ऑडिएबल
Banaras. Yes, sir.
yes ma'am I am going to share my slide ma'am wait a few seconds. Good afternoon everyone. Myself Pasupati Nath Singh and my presentation title is Assessing Climate. Assessing climate change impact on tomato production in central India. I am covering all the district of Madhya Pradesh. A process-based yield simulation for mid and far future scenario. And this is the outline of my presentation. And this is the picture of my whole work, which where I'm going to present here.
Pashupati,
I have chosen, hello.
you leave introduction, you leave method and material. Okay.
Okay, sir.
You
Okay,
go
sir.
ahead. Everybody know about tomato. So method material, you leave it. You come to
Okay,
the
sir.
objective and then discussion and result. Okay.
Okay, sir. Okay, sir. The objective of my work to evaluate the effect of projected change in mid for future climate scenario and yield for tomato crop in central India. Here I have using a DSAT process-based crop simulation model, and second one to analyze the influence of key climatic variables such as temperature and solar radiation on tomato crop phenology. I have put hello.
Good.
Okay, sir. Productivity under changing climate condition to propose adaptation strategy including management practices and climatic technology to mitigate the negative impact of climate change on tomato production. And this is my study area. I have taken 28 grids and covering the whole area of Madhya Pradesh. I have chosen the Madhya Pradesh because Madhya Pradesh is the largest tomato producing state of India. And in methodology, study was conducted by utilizing the output of 8 global climate model. To avoid the biasness of result, data was generated from each global climate model under 2 scenario and 2 distinct period. I have used two time frame, that is mid future and far future. Here is the duration of 30 years. And in DSAT, I have used a crop grow tomato model phenology with yield and additional CO2. That is for mid future, and what is the additional CO2 for far future. And to avoid the biasness of result, there are 32 climate scenario was generated to analyze the uncertainty associated with extent of change in tomato performance. And this is the outline of my general methodology of tomato crop grow model. You can see that. And this is the projected change in maximum temperature all over the Madhya Pradesh. Annual departure observed data from reference period shows rise in temperature all over the Madhya Pradesh. In some districts like Dhar, Jhabua, Devas, and Burhanpur, that is the southern western region of MP, under both the scenario.
Just a minute, sir. Okay. I request only Pasupati sir, you just unmute it. बाकी सबको मैं request करती हूँ mute करने के लिए.
with code and the काय जे असं ते सगळे किती
Okay,
ग्राम
ma'am.
बाय
Okay, ma'am.
Okay, sir, continue, sir.
ग्राम.
And this is the variation in minimum temperature all over the Madhya Pradesh, as depicted in the map. Annual departure of observed data from reference period show a large rise and fall in temperature, with exception in some districts that lie in the middle of Madhya Pradesh, like Raisen district, Bhopal district, and Damoh. So a decrease in projected minimum temperature under both the scenario of mid-future time frame. And this is the variation in solar radiation depicted in this map all over the Madhya Pradesh. Under both the scenario, SSP 4.5 and SSP 8.5 climate change scenario, the model ensembled, I have here used 8 GCM. Solar radiation, the model SSCM2, CMCC, ESM2, Foggles 3, and some more projected an increase in solar radiation except NAR-ESM2 under both the scenario of mid-future and far future. In the middle region and western part of the Madhya Pradesh, that is jointed to the Rajasthan and Gujarat region. Climate model SSCM2 and NAR-ESM2 show overestimated and underestimated projection respectively under both the scenario of climate change, mid and far future. And this is the projected change in yield under mid and far future scenario. You can see that I have compared these changes with IMD baseline data of 30 years 1980 to 2009. Under both the scenario, SSP 4.5 and 8.5 climate change scenario for different time frame show a decrease in yield compared with baseline. Result conclude that yield decreases with variation in magnitude, that is model MPPI ESM 12HR show a maximum reduction about 47% in reduction in yield under future and SSP 4.5 scenario. Region of Madhya Pradesh like Damoh, Mandala, Satna, Balghat are most vulnerable for far future under SSP 8.5 scenario. So increase the baseline condition, and region like Morena, Chhatarpur, Sioni, Chhidwara for the mid future under scenario majority of the model here. So a maximum decrease from the baseline. So we can say that Morena, Chhatarpur, Sioni, Chhidwara are the most vulnerable parts of the Madhya Pradesh for reduction in yield in upcoming years. And what are the comprehensive strategy we can take to avoid these reduction in yield? And first of all, here I am going to say that I have validated our model with 5-year district data, past district data taken from Madhya Pradesh, and all the model exhibit a moderate to excellent agreement with observed data, while the correlation value are mostly above the 0.75, and RMST is very low, and percentage of biasness is also very low. Indicate that here some space for improvement. The variability in yield can be more effectively captured by incorporating or refining existing one. This is due to local variation in climatic factor. And comprehensive strategy we can take to avoid these reduction in yield, like make a policy for future, use climate resilient variety of tomato, to make a policy for farmers, and soil, increase soil health to reduce the resilience and productivity. They reduce the greenhouse gas emission. And final, we move towards our conclusion. All the climate projection predicted a progressive increase in temperature of the total growing season individual month, that is from October to March, under the both scenario for both the time frame. Impact assessment reveal that vegetative growth and thesis and fruiting periods of tomato yield are most vulnerable. From these stages, flowering and fruiting stage of tomato are highly sensitive to climatic variation. There are many uncertainty associated with climate model output. It was revealed that MPPI SM2 and SSCM2 have predicted a higher yield reduction under SSP 4.5 scenario for mid-future, while ESM reduction across all over the MP under both the scenario of SSP 4.5 and 8.5. Region like Morena, Chhatarpur, Sioni, Chhindwara, and also I have include a part of Bundelkhand of Madhya Pradesh represent the most vulnerable region during the mid and far 21st century within the steady site. There was a complementary increase in solar radiation along with rise in temperature that could be offset the tomato yield. And future work or future prospectus, what we have will do, increasing tomato yield in future time frame despite changing climate condition of Madhya Pradesh will require policy formulation for climate smart agriculture, expansion of multi-crop and regional simulation by incorporating remote sensing and machine learning algorithm, weather forecasting and advisory service, incentive for sustainable practices. And these are the references, and thank you all, and you can ask
Thank you so much. Thank you so much, sir. Next we have Rahul Jitendra Janpakal.
Welcome.
Can we have Rahul
Yes.
Jitendra? Yeah. He's here online only. Please share. Okay, done.
Good afternoon, esteemed colleagues and researchers, chairmen, organizers, for giving opportunity for presenting my PhD topic, that is in vitro studies on micropropagation, validation of genetic fidelity and biochemical assessment among Butia monosperma. And I am from MGM University, Chhatrapati Sambhajinagar, Maharashtra. So background of the study that Butia monosperma belongs to the family Fabaceae, is an endangered valuable woody plant and commonly known as flame of forest, bastard teak, dhak, palash or porso This plant species is much demand in folk medicines and have phytochemical profiles which include different secondary metabolites like imides, flavonoids, aliphatic compounds, lactones, alkaloids, sterols, and miscellaneous compound. It is also extensively utilized for lac cultivation and is the single largest producer of Rangini lac from India. These species can be conventionally propagation but have limited scope due to poor seed viability, low seed germination rate, and genetic variability, which restrict conventional propagation. As micropropagation is an alternative technique which is reliable, rapid, and effective for large scale production to true type elite plant and can preserve genetic integrity. So my objective of my research was to optimize composition, concentration of various components to support regeneration, multiplication, and regenerant differentiation in somatic tissue through direct organogenesis. Second objective was to establish standardized protocol for in vitro, ex vitro routing of regenerated microshoots and acclimatize that plant to the natural conditions. And the third objective was to comparative metabolic profiles of secondary metabolites of leaves of in vitro plants and donor plant through GCMS analysis and to check or to validate the genetic validity among tissue culture raised plant using molecular markers. These were my objectives of my research. So the materials and methods in that I use explant nodal and internodal segment of 1 centimeter. The media was MS media, muraceous and scoop. Cytokinin tested was benzyl aminopurine, kinetin, metatopylene, and 2-isopentyl adenine at the concentration of 1 to 10 micromolar. Then oxine also tested in that IA, indole acetic acid, indole butyric acid, naphthalic acetic acid of 0.1 to 2 micromolar concentration I have tested. And the stages studies like shoot regeneration, root induction, acclimatization. Then GCMS analysis was done by ethyl acetate solvent in both plant control and tissue culture raised plantlet. And fidelity was tested by using ISSR primer. I used 20 ISSR primer, and the statistical design I applied was completely randomized design, where I repeated experiment 3 times. So different cytokinins and with different concentration I use. In that I use BAP, kinetin, metatopylene, and 2IP. In that I found best result in 2.5 micromolar of concentration, where I found good result in uh, BAP and metatopylene, and moderate response was found in kinetin and 2IP. These were my result. In this shoot regeneration was obtained after 8 weeks of incubation, where in benzyl aminopurine I found 88% at 2.25 micromolar concentration, where I found highest shoot induction frequency. And in vitro root induction, where I used different oxines, in that indole acetic acid, indole butyric acid, and naphthalic acetic acid I use. In that I found good result in indole butyric acid. About 93% root induction was done under oxines. These are the results, where I use in vitro 1/2 ms media with 1 micromolar IBA, which yielded higher root induction, about 93%, and ex vitro, where I use different materials like different potting mixtures like soil, coco peat, vermiculite, then perlite, and different concentration, and I found good result in soil and vermiculite at 1:1 ratio. I also tested them in days like 10, 20, and 30 days, and the best result was found in soil and vermiculite. These were the acclimatized plant. After that, in the field condition, I found 80% plants survive in the field conditions also. Then I have done phytochemical screening, where I study secondary metabolites from both the plant donor and in vitro raised plant, where I use different solvent like acetone, ethyl acetate, ethanol, methanol, then methanol, chloroform, and hexane. And these were my samples. Then I found good result where in donor plant I found 19 compounds. In that there were many compounds like neophytidine, squalene, stigmasterol, lupianol. These are all antimicrobial, antibacterial, and anti-cancer properties they have, and therefore they are medicinally important. Then, if you see in micropropagated plants, I found 38 compounds, different compounds. In that, some of the compounds were similar, and in tissue culture plant, I found more compounds, like about 38 compounds I found in that, and they have highest concentration of all these properties, antimicrobial and antifungal properties. They have larger production than the donor plant. So these were my GCMS chromatogram of ethyl acetate of donor plant, and GCMS analysis of ethyl acetate leaf extract analysis of tissue culture raised plant. And in that, the highest peak were found in tissue culture raised plants, and about 38 compounds I found. Then to validate the genetic fidelity, I use different ISSR markers. In that, I use ISSR primer, about 20 ISSR primer where I use to test the genetic fidelity. And the result of ISSR primer for assessment was done in that. I found good result in UBC 811 where one was the mother plant, and the rest of them were all very tissue culture raised plant, and I found good monomorphic banding pattern in all the bands, all the gel, and about 10 monomorphic bands were found highest. Then I have done cluster analysis and genetic distance. I measured of ISSR where I found about 90% similarity with mother plant. The plant have good genetic stability. And from that, I concluded my research that this research successfully established rapid micropropagation plantlet, ensuring high efficiency and minimum genetic variability. The optimum use of BAP for shoot induction and IBA for root resulted superior growth and survival rate. Then soil and vermiculite 1:1 ratio mixture gives optimal condition for plantlet survival. Then different phytochemicals have different bioactive compound as compared to the other. Then genetic fidelity I tested and I found good result. Then what are the outcomes of this finding? Like this study provide valuable framework for large scale production, conservation, and sustainable utilization of plant for medicinal and commercial purpose. This study provide valuable data on micropropagation, biochemical profiling, and genetic fidelity, which serve for reference for future studies. It can boost pharmaceutical industry for enhancing the production of bioactive compound for developing new drugs, and ensure high availability of high quality genetically stable plant material with enhanced bioactive properties for therapeutic and industrial applications. These were my references. Thank you, sir. Please, if you have any question, you can ask me.
Thank you so much. Next, in BC, Hema Malini P. Can we have Hema Malini P from ICAR IIHR Bangalore?
Am I audible, madam?
Yeah, you're audible. Please share your slide, ma'am.
Yes, ma'am. Just 1 second. I think he has to stop sharing.
How is your director, Vera?
No, she is here now.
Yes, madam. My screen is visible.
Yeah, you're visible, and please start your presentation.
Yes, ma'am. So good afternoon, everyone. So my topic is leveraging generative artificial intelligence for predictive stress responses in tomato cultivation. So that's an climate smart agriculture framework. I'm Hema Malini, working as a research scholar in National Innovations Climate Resilient Agriculture Project, IIHR, Bengaluru. So, this study presents an innovative framework integrating generative artificial intelligence and retrieval augmented generation to simulate the optimized irrigation responses to master stress in tomato cultivation. So the proposed system analyzes experimental data from two irrigation regimes. So one is the optimal irrigation 100% and one is the deficit irrigation 50% at three growth stages. So this framework predicts and recommends the optimal irrigation strategies by combining real-time sensor data with artificial intelligence generated simulations. And this is my experimental plot setup. So these are all the plant lines with pressure compensated drip irrigation system and with soil moisture sensors installed with solenoid valves and LoRa nodes. This is communicate from the sensor to the cloud and it is sent through Bluetooth or Wi-Fi technology. So all the data collected from the soil moisture sensor is sent through the Wi-Fi to the LoRa network and from the LoRa network to the cloud storage. And while irrigation, the soil moisture detects the value, it sends control to the cloud storage. From there, the irrigation also is triggered. So it is a completely automated experimental system for tomato plant. So this is the sensor-based irrigation system what we set up and we collected the time series data from this. So soil moisture values are predetermined based on specific soil requirements, ensuring efficient water management. When the soil moisture sensor detects a decrease in moisture level below the set threshold, it sends a signal to the microcontroller board. So the controller board interprets the signal and triggers the solenoid valve to open, allows the irrigation. So the entire operation is coordinated by this irrigation controller. So data regarding the soil moisture level and how much the water is applied is also recorded using flow meters and logged and stored in the cloud data for further analysis and monitoring purposes. The cloud storage facilitates remote access. Even remotely also we can on off the motor and everything we can do. So the system promotes water conservation by building targeted irrigation. So this is the experimental setup. The soil moisture sensor, whatever we used is the watermark soil moisture sensor. And the values, if the sensor gives the 0, it is highly saturated and the soil is very wet. And if the maximum value of the sensor is 200, it is completely dry. And we have to create one slurry and we have to install the soil moisture. So this is the range. 0 to 10 kilopascal is the saturated soil moisture and 40 to 65 is the deficit moisture. That is more than 50% deficit moisture in the soil, and more than 65 and above is the plant will be completely wilted. This is the standardization we did. And the crop we experimented, this is the first experiment. This is tomato, Arka Rakshak variety. So the treatments are 100% and 50%. Here the soil moisture sensor we have installed and the soil type is clay loam. And the sensor is installed at 15 centimeter root zone depth. So the data collected on soil moisture, temperature and rainfall using the sensors. So the experimental setup 100% and 50% irrigation regimes at 3 growth stages. One is vegetative, flowering and fruiting stages. And the AI model, whatever we have development is training a generative artificial intelligence model for simulation of data, integrate historical data through retrieval augmented generation for improved accuracy. So what the RAG component does is it pattern matches with the historical data and it will retrieve and it will compare. And the generative AI components generates or predicts, simulates the soil moisture and the irrigation prediction. So this is the working of retrieval augmented generation is nothing but a machine learning framework that combines generative models to enhance the generation of contextuality, accurate information output. Say for example, retrieval model nothing but searches and retrieves the relevant data from the knowledge source of the cloud, soil moisture data or irrigation data or temperature. It retrieves from the cloud. What the generator model does is processes the retrieved information and combines it with the query to generate a context-aware output. And why RAG is important? It improves accuracy, combines historical learning with real-time adaptation also. It will learn back. And how it is different from traditional model. Traditional model is a static knowledge. Whatever the data we have presently, with that only it will work. RAG, the retrieval augmented model generation, is a dynamic model. It updates as and when the data is updated in the cloud. It continuously gets the data from the cloud and it updates automatically to give new predictions, and it is highly dynamic. And in agricultural context, it matches the historical pattern matching, learn from the past irrigation and soil moisture responses, adapting to local condition, and improves the decision accuracy. And see, this is the model. Here the current data is inputted here. The RAG components, it will take the historical pattern, it will retrieve, it will match the pattern matching, and it will give the response. So here historical data is the, it will take into an output, it will give us so what is the soil moisture prediction and how much is the irrigation required for the particular soil moisture, and how these prediction models evolved. So initially we started with simple moving average and exponential moving average, then AR model, ARM model, and ARIMA and SARIMA. These are all the traditional prediction models. And here, whatever the new machine learning models we have is deep learning and recurrent neural networks, say for example, long short term, LSTM, and Prophet, which is the forecasting model by Facebook, and DeepR. So like this, the generative AI model, whatever we have chosen for this study is time GAN. Time for time series and generative adversarial network. So this is the model we have chosen. So what this generative AI is does is, it's a specialized branch of artificial intelligence that focus on creating new content by learning from the vast data sets. So generative AI model consisting of two components. So what the generator and discriminator. So what this generator does is, it tries to create a synthetic data that mimics the real data. What the discriminator does is, it tries to distinguish between the real data and the synthetic data. Whatever the data generated by the generator is correct or not by comparing with the historical data. In time series data, the generative data learns to create future sequences based on past patterns, and this discriminator improves the generator by performance by identifying the unrealistic sequences. If it is a very more deviation from the original data, then discriminator gives a penalty. So the generator will go again and it will generate the data for prediction. So this is the historical data that is stored in the cloud. It is a timestamp, and with Rakshak is the variety, and what is the soil moisture for 100% irrigation, what is the soil moisture for 50% irrigation, temperature, humidity, and rainfall. And we just did this analysis with starting with ARIMA model, and this is the prediction in ARIMA model for soil moisture, and this is the prediction with SARIMA model, and this is the prediction with our proposed time GAN model. See this, the prediction is too closer. And this is the root mean square error. For ARIMA, it is 7.6, and for SARIMA, it is 5.6. And for the time GAN, which is too close, it is 2.46. So based on this, this is a univariate. This is one variable, and with multivariate analysis also we did with moisture, rainfall, and what are the irrigation. So based on that, we try to predict the how much volume of water should be irrigated for that particular soil moisture, and different growth stages for complete field capacity and for 50% irrigation under 3 different growth stages. This is the actual and this is the predictor. So the actual and the predictor, the model performs. This shows that the model performs very well here also. And the added advantages, like how we this can be integrated into large language models. We use the OpenAI's API. So with that API, if we can type and ask, how we asked in ChatGPT also, we can type and ask what is the highest soil moisture value in the past month. So based on the data, it will analyze and it will get the data, and it will give the output as the highest soil moisture was observed on this date with the value of 80.7. So immediately, if you want to see any data also, we can type and we can get that whatever the data we want. So this is the integration with large language model. And this is the future work, how this model can be integrated in the future work, like for pest and disease outbreak management also. Conventional methods rely on reactive measures often applied after significant damages occurred. So this AI-powered early warning system we can develop using this generative AI and RAG model. And drought and long-term water management can be done, can be using this generative AI model. We can generate drought impact scenarios on soil moisture and yield using this generative AI models, and retrieve past performance data for drought-tolerant varieties using this RAG and recommended alternative options. So as a conclusion, generative AI and retrieval augmented offer innovative solutions for moisture stress management in horticulture. AI-driven decision support enhance enhances sustainability and future directions, expanding AI integration for stress scenarios. Thank you so much for giving me this opportunity.
वेरी गुड मेहरा साहब कैसे हैं ठीक है चलिए लास्ट
Hello. All right, Noor Fatima. Noor Fatima. Okay, we left out with Dimple Kamboj.
डिम्पल कपूर has come where
Hello, check. Dimple Kamboj.
Yes, ma'am. Ma'am, I will present after 5 minutes.
No, you are the last person to present right now. So I request you to present right now only. We don't have anyone left. So please kindly share your slide and start the presentation.
Please give me 1 to 2 minutes, ma'am.
Okay, only 1 to 2 minutes. Noor Fatima. No one is here, right? Okay. After 1 minute, we want your presentation, sir. Okay.
let us give him 1 minute
Dimple, are you ready? We will be concluding today's session 2, and the last participant is Dimple from PAU Ludhiana. Dimple,
Yes, ma'am. I am audible, ma'am.
yes, you're audible. Please kindly share your slide. Please share your slide, sir.
My screen.
Are you listening me? Am I audible to you, Dimple, sir?
Yes, ma'am. My screen is visible.
No?
no
Yes, sir. Yes, ma'am.
Ma'am, Noor Fatima, she is absent.
Ma'am.
Yes. Can you go through the option of share your screen? Are you able to share it or? Okay, it's done.
Hello, ma'am, screen is visible?
It's not visible properly.
Ma'am, now screen is visible, ma'am.
It's not visible, your presentation stand delivered. You are taking more and more time, you ask for 30 minutes. Thank you very much.
Thank you so much. You are closing the session for today. Thank you everyone, all the presenter. Thank you so much, co-chairman, and thank you so much, session convener and session coordinators also, and rapporteur also. Thank you so much.
Well, there were very, very good presentation, except two. One was okay, but too much. Second was not serious in making the presentation. And rest of the presentations are very good. As per their, though they are student, very good slides, very good information, very educative, and they are doing very well, but still their teachers have to advise them to make short. But one of the presentation from IARI, wonderful. He has written minimum, good picture, good photograph, good material, good presentation. And then another one was also good. Others have also made good presentation. And those young students, they have been given opportunity to make the oral presentation, but they should also, when attend these seminar and conferences, learn from each other. I think, thank you very much, very much. I thank the organizer for giving me opportunity to learn from you, learn new things in the, apart from maze. I am a scientist, but I am learning many things. Thank you very much, madam. Now it's yours.
Thank you, sir.
खत्म हो गया ना, तो है नहीं।